So let's take a look now at the second part of case study ex4. And the second part is going to demonstrate how to use a bunch of flux operators like subscribe, flat map, and from array to create, multiply, and display big fraction objects asynchronously. This particular example does not apply back pressure, although it does use the back pressure subscriber for blocking purposes. And you'll see how that's going to get used here to wait for all the asynchronous processing to be done. We're also going to show how to use a couple of interesting mono operators, including from supplier, map, flat map many, which is a very interesting mono operator, and subscribe on. So you see, these are some of the things we're going to get there from using the monos. And then we're also going to show how to use this blocking subscriber in a back pressure unaware manner by awaiting for all the asynchronous processing to finish. So let's go ahead and take a look at this code, which as usual is in the ex4 project in my reactive flux folder in my live lessons GitHub repository. So here we are in the main entry point of this test program. We're going to take a look at test fraction multiplications blocking subscriber 1. And that particular test method is registered along with the other test methods. And then we run the async task barrier to run everything in the background. And we block the calling thread and print out the number of tests that completed successfully. So let's go ahead and take a look at this implementation. So here is the FluxEx class, the example class. We create a random number generator, which we'll see how it gets used. Down here, for this method we're going to look at, we create an array of big fraction objects. You can see we have, everybody has 100 as the numerator, and then 1, 2, 3, 4, 5, 6, 7, 8 as the denominators. Note there's no 0, so we don't have to worry about divide by 0 exceptions. Next thing we're going to do is we're going to create a blocking subscriber. So remember, back pressure subscriber was the class we looked at part 1 in this video. And we're going to make one of these things with a little factor method we'll look at in a second. And we're going to pass in the string buffer. We're going to pass in long max, which just means don't have any back pressure. And we're going to pass in true, which means please go ahead and log. So let's look at make blocking subscriber. You can see what it does is it makes an instance of a back pressure subscriber. And we pass in a whole bunch of little lambda expressions. The first lambda expression says, if we're logging, then go ahead and add the big fraction to the string buffer. If something goes awry, we're going to display the results. When we finish, we're going to display the results. And then we just pass in the request size and pass in the string buffer. So that's how we make one of these guys. We then take that, we're going to use it at the end of this little pipeline, as you can see here. And this is an interesting pipeline. It starts out with a mono. So remember, mono is the form of a type in Project Reactor that emits one thing or 0 things. In this case, it's going to emit a single large random big fraction. So we're going to emit one thing. We're going to use the random number generator, and it's going to be reduced. So we have a reduced big fraction. We're then going to take that one reduced big fraction, and we're going to use the flat map many method. Flat map many is an operator that's defined on mono that will take a single input and then produce a flux as output. That's where the many comes from. I don't know why they didn't call it flat map flux, but whatever. So what we're going to do here is we're going to take that big fraction array and we're going to generate a stream of big fractions, a flux stream of big fractions. And then for each of those big fractions in that array, we're going to use flat map to multiply the big fraction that we generated randomly by all the different big fractions in the big fraction array. So you can basically think of this as kind of like a parallel for loop. So it's as if we're looping through the elements in the big fraction array, and we're multiplying each of them by the randomly generated big fraction. And we're going to do it in the parallel scheduler pool. So remember, the parallel thread pool is a pool that's intended to be used for computationally intensive or CPU intensive tasks. So if we look at multiply fraction, you can see that it takes the big fraction 1 and big fraction 2. It makes a mono from them. It will subscribe to run this on whatever the scheduler parameter is, which in this case is the parallel scheduler. And so it's going to end up multiplying big fraction 1 by big fraction 2 in a thread from the parallel thread pool. And just always remember that when you use subscribe on, it actually goes back up to the beginning of the pipeline or the chain here and starts the processing in the background here in the from supplier portion. From supplier is dynamically bound, so that'll run in the thread that's being subscribed upon. So all of this processing takes place in the background once we call subscribe, and when we call subscribe, we pass in the back pressure subscriber, even though it's really the blocking subscriber. And we're then going to go ahead and wait for all the asynchronous computations to complete by calling the await method. So this will block synchronously in that calling thread while all the other computations up here are running in the background using the parallel scheduler that we pass as a parameter. So pretty cool example of how to essentially do parallel computations using features from Mono and Flux.